Okay, so in this enrichment, the students on campus and online have access to this file as well. It's posted on the course webpage, and then if you were on campus, and we just did it in class, some nomenclature problems so that we're experts at naming organic molecules that are substituted alkanes. So if you're watching this video online, what I recommend is that you pause the recording, take a minute and try these for yourself. That one's kind of funny. There we go. So there are the first three. Well, actually, you could see number 4 in there as well. Pause the video, take a minute, try it on your own, and then when you're ready to see the answers, you can resume the video. Here are the next several, 4 through 8. Try those. Pause the video. When you're finished, resume. And there's 9 and 10. And then for the next few, we're drawing skeleton structures, so we're using the skeleton notation. And then for the last few, I'm asking you if these structures are named properly. So I gave you a structure, and then I gave you the name. So again, you're getting a chance to pretend that you're the teacher. So if this is the structure and this is what your student wrote, did your student get it right? This is the structure, this is what your student named it. Is that correct? So let's see how well your students do. There are 17 through 19. And then there's the last couple, draw structures, and I say either skeleton or condensed molecular for these two substances. All right, lots to do. So let's go through these. Naming using Ipek rules first. So one of the things that you need to know about this kind of notation is that when you've got something like this group, you see how it says CH2, CH3, and then a parentheses 2? What that means is that those two are on that carbon. So if you draw that, you need to flesh it out. Okay, so it would be CH3, CH2, C, and then CH2, CH3, CH2, CH3. Does that make sense? And then the rest of the chain. CH2, CH2, CH3. Okay, so now we just need to identify the longest chain. It doesn't matter where you start. You can start here, here, or here. You're going to get the same answer either way, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it also doesn't matter which one you pick as carbon number 1, because you're going to end up with 2 ethyl groups on carbon 3. Right? So you could pick this or this as carbon 1. Makes no difference. A lot of students like to just keep it linear, so let's keep it linear. 1, 2, 3, 4, 5, 6. So the name of this would be what? 3,3-diethyl. Yep. Hexane. Good. All right, number 2. We need to figure out the longest parent chain. So let's count all our options. Either one of these is going to be the same. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Pretty much all our options. So which one is it? It's a 7 carbon chain, right? Carbon number 1 going to be down here or up here? Down at the bottom, right? And it doesn't matter which one of these you pick as carbon number 1 because it's still going to be a methyl group on carbon 2. So because my seam of the board's right here, I'm going to pick this one. 1, 2, 3, 4, 5, 6, 7. Okay, so we've got, what kind of group is this? It's a 2 carbon chain, so that's a what? Ethyl group, yep. And then all 3 of these are methyls, right? So we put them in alphabetical order, right? So the name is 4-ethyl, and then 2,3,3, what? trimethyl heptane, right. Good. All right. Kind of made this handout a little bit too smushed for writing on the board. That's okay, we can do it. All right, number 3, we're going to count the longest parent chain. Now this is a carbon right here in the middle. A lot of students get confused when they see a zigzag line like that. That isn't actually a carbon right there. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I think 9's our winner, don't you think? All right, so if we're doing a 9 carbon chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to start here or here. We're starting on the left, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's figure out what our substituents are. This is just a what? That's just a regular old methyl, right? Nothing fancy there. What's this? This one right here. So it's a 1, 2, 3 carbon chain, right? 1A, 2A, 3A. So this is a 1 methyl propyl, right? And what's this one? Right, this is a methyl ethyl, 1A and 2A. So this is a 1 methyl ethyl. All right, so we got some branch substituents going on here. So now we just need to put these in alphabetical order. Methyl versus methyl propyl versus methyl ethyl. Methyl comes first, right? So we would name this 2-methyl, and then methyl ethyl comes before methyl propyl. So 5, 1 methyl ethyl, and then 5, 1 methyl propyl, and then it's a 9 carbon chain, nonane. So that's our final answer. Okay, do you see where you made your mistake?
Yeah, I didn't know that 5 was a carbon.
Okay, yeah. When you see a crossing like that, there is still a carbon there. Yeah, that makes it tough sometimes. All right, let's scroll up, do the next set. Okay. So here, we've got another one of those branched configurations. All right, so when you see this parentheses with a 2, that's telling you that these 2 are actually on that carbon. This telling you that this is actually on this carbon. And that's telling you that there are 2 of these on that carbon. All right, so you need to flesh this out. Well, I mean, you don't have to, but it makes it easier to name if you flesh it out. So CH3, CH2, C, and then CH2, CH3, CH2, CH3, then CH, oh, that's going to crash, I'm running out of space. Let's draw this one going this way. And then CH. CH2, CH2, CH3, CH2, CH2, CH3. All right, a lot going on here. We need to find the longest parent chain, right?
I have a question about that.
Sure.
How do you know the last one's not on the parent chain?
You could have drawn it right there.
Like, I mean, you can't, like the top 3 C's. Could you count those 3 and it would be a 8 carbon chain? How do you know
So you
that's
go 1, 2, 3, 4, 5.
6, 7, 8?
Oh, so that's what we're going to do right now. We're going to figure out the longest chain. Yeah, that's what we're going to do. That's why I fleshed it out, so that we can count them off. Yeah. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Either way you go, you're going to get 8.
Even though that's parentheses around it, it can still be.
Yeah, because this is telling, this parentheses is telling you that that's on this carbon.
Okay.
So it's attached to that carbon, yeah. So in other words, you're taking this and it's like you just sat on it, and so you smushed it down. So it's just another way of notation. Yes, this 2 is telling me that everything in the parentheses, both of those, there are 2 of them on that carbon. And this parentheses is telling me there's 1 of those on that carbon. And this parentheses, there's a 2 telling me that there are 2 of those groups on that carbon. Does that make sense? So because we're in such close proximity, let's use a different color here. So 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. Either way, it doesn't matter. Which way is going to get me to my first substituent first? Counting from the left or counting from the right? Right. 1, 2, 3 versus 1, 2, 3, 4. So 1, 2, 3, 4, 5. Now you can go up or you can go down. Doesn't really matter. 6, 7, 8. Okay. So now we just need to name everything. So we've got ethyl, ethyl, right? Those are both ethyl groups. This is a methyl group. And what's this? A propyl group, right? So we've got ethyl, ethyl, methyl, and propyl. So we need to go alphabetical order, right? So this would be what? 3, 3, diethyl. Then what? M comes before P, right? So 4 methyl. And then 5 propyl nonane. Nope, not nonane. It's octane. 8 carbon chain. Do we feel good about that one? All right. This one is in a really inconvenient spot because it's right on that C. That's okay. We'll make it work. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so let's count them off. 1, 2, 3, 4, 5, 6. How many substituents does that give me?
I got 7.
Oh, where's the 7?
The top right corner down to the bottom.
1, 2, 3, 4. 1, 2,
Top right.
3, 4. Top right. Good call. Good call. Didn't count all my options. See, I would have got a point off. So yes, that is correct. 1, 2, 3, 4, 5, 6, 7. You're right. Okay, so let's name all our substituents. This is just a methyl, and so is this. And then what is this? 1A, 2A. So that's a 1-methyl ethyl, right? Okay, so we have, all right, over here, I think I've got enough room. Methyl comes before methyl ethyl, right? So we say 2, 5, dimethyl, and then what? 4, 1, methyl ethyl heptane. Hopefully that last little snippet made it into the video. Okay. Number 6 is significantly shorter, right? 1, 2, 3. Well, that's not going to work. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? You can pick any one of these as carbon. You can pick it at either one of these three as carbon number 1, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Either way, you're going to get the same answer, so long as you pick one of those three. So what's the name? Careful, it's not 2-dimethyl. I'm going to write what you said. If you write 2-dimethyl, that's saying that there's only one methyl group. 2,2-dimethyl, right? There we go. Okay, number 7, you can pick literally any one of these carbons to be number 1, right? Any one of them, because you're going to get the same answer either way. So just for fun, let's go horizontal. 1, 2, 3, 4, 5. So what's the name of this?
3,3-diethyl.
Yep, 3,3-diethyl. What? Pentane. Good. And now number 8. A lot of students would tell me that this is a 1, 2, 3, 4 carbon chain with an ethyl group on it. Is that correct? It's just hexane, right? That's it. How come this is just hexane? There are no substituents here, right? 4 carbons, 4 carbons, 4 for bonds, 4 bonds, 4 bonds, 4 bonds, 4 bonds, 4 bonds. There are no substituents here, right? So it's just hexane. Good, 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 good. That's a trap a lot of people fall into. Glad you did. Okay. Okay. This one's pretty easy too, right? You could pick any one of these to be carbon number 1. Just for fun, let's do this. So what's the name here?
2-methyl.
All right, 2-methyl propane. And technically, would it be okay to omit the 2? Because think about it. If this methyl group were on carbon number 3, would that still be a propane? It'd be just butane, right? So technically, you don't even need that 2. I mean, I'm not going to count you wrong if you put it. But there's only one place for a propane to have a substituent. See what I'm saying? But I wouldn't count you wrong if you put it. It's just unnecessary.
So can there ever be a methane? Like what is that like?
Methane? That's the only way, that's the only methane you can.
So it can't have like.
It could have a substituent. Yeah, you could put a chlorine here. And you just call it chloromethane. Again, the 1 is redundant because there's only 1 carbon. Or you could have 2 chlorines. That would just be dichloromethane. Or you could have all 4 of them be chlorine. This one would be trichloromethane, right? So you can have substituents, yeah, on a methane. I mean, if you had all 4 of them, it'd be tetrachloromethane. But the 1 would be redundant because there's only 1 carbon. Just like here, the only way a propane could have a methyl group substituent is if it's on carbon number 2. Because if it were on carbon 1 or carbon 3, it wouldn't be a propane anymore, it'd just be butane. Okay, this is another one that we need to kind of expand. So this parentheses here tells me that it's on that carbon. This parentheses tells me it's on this carbon. This parentheses tells me it's on this carbon. This parentheses tells me that there are 2 of them on that carbon. All right, so let's see. Scoot over as much as I can so I don't run into that seam. CH3, CH, CH3, CH, CH3, CH, CH3, CH, CH3. All right, squeeze it in there. Okay, does it matter which end we pick as carbon number 1? No, we can count from the left or count from the right, right? Because you're going to get 1, 2, or 1, 2. You're getting to your first substituent on carbon number 2, either direction. So just for fun, let's go this way. Make things different. Okay, so what's the name of this? 2, 3, 4, 5, what?
Oh, methyl.
Tetramethyl, right? Because it's telling me that there's a methyl group on carbon 2, carbon 3, carbon 4, and carbon 5, right? And then hexane. Do you see where that one comes from?
Yeah.
We good on that one?
Yep, I drew it different.
Oh, okay. Do you see how we got from this to this? Okay. Anytime you see anything in parentheses, just know that it's on the carbon immediately next to it. So this is on the carbon here, this is on the carbon here, and then there are 2 of them on this carbon. All right. I think for the next little bit, I'm going to switch out of this share mode and just put it into regular old Word so that I can hit enter a whole bunch of times and give myself space. That way I can have space. There we go. That's better. Okay, draw skeletons for the following. So this is a pentane, so that's a 5-carbon chain, right? 1, 2, 3, 4, 5. 1 chloro. You could have drawn it going up that way too. 1, 2, 3, 4. 4 methyl pentane. Now you could have a chlorine on carbon 1, but could you ever have a methyl group on carbon number 1? No, that means that you just misidentified the parent chain. All right. This one you had trouble with? Okay. So hexane, so that is 6 carbons. 1, 2, 3, 4, 5, 6. 1, 5. So just for fun, I'm going to draw this one going up like that. 1, 2, 3, 4, 5. Iodo means iodine. So that's just 2 iodines. So when the substituents on carbon number 1, whether you draw angled down or angled up, I'm not going to get obsessive about it. All right, let's do 13 and 14. Oh, need a space. Okay, butane. 1, 2, 3, 4. 2 fluoro. 3 methyl. Do we agree? Yeah. And last one in this section is decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 bromo. That's a BR. 2, 3, 4. 4 propyl. 1. Oops. That's some funky angles going on there. 1, 2, 3. And that's it. Do you agree? All right. For part 3, you're going to pretend like you're me and get to be the teacher. If this is the structure that the students were given and that's the name, did the student get it right? So let's find out. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. All right, so I already know the student got it wrong, right? Because they're calling it a pentane, but it's a 1, 2, 3, 4, 5, 6. It's a 6-carbon chain, right? So we know the student's going to lose at least 1 point. Right, 1, 2, 3. Skip number 4. Learn how to count, Dr. Brooke. Okay. Oh, that cursor's going to drive me bonkers. Flashing in my face there. All right. So now we just need to identify our substituents. That's a methyl group, and that's an ethyl group. Right, so the name, the correct name is 3-ethyl 2-methyl what? Hexane, right? So for instance, if you did this on a test, this would I usually count names, depending on how complicated they are, 3 to 4 points, depending on the complication. Sometimes even more than that, right? If there are lots of scary, crazy substituents, and that obviously make it worth 1 point. If you just misidentified the parent chain, but your substituents are correct, right? Because this student said 1, 2, 3, 4, 5. Based on numbering it this way, that would be a propyl group, that would be a methyl group. Right? So they applied the nomenclature rules correctly, they just misidentified the parent chain, so that'd be like a -1. Okay, let's see if this person gets this one right. Let's flesh it out a little bit. So CH3. Now when you see this kind of notation, you can't have 3 CH2s on this carbon. That doesn't make sense, right? Because there's no way this carbon could have 3 hydrogens on it and 3 CH2s. That's nonsense. So when you see this CH2 with 3, that's just telling you it's a chain of 3 CH2s. So CH2, CH2, CH2. Okay, that's what that is. Then CH, then again, CH2, 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 CH3. And then down here we've got C, CH2, CH3, CH3, CH3. Do you see how this one's different from the previous ones we saw? Because this would give a carbon with 6 bonds, which doesn't make sense. Okay, so now we just need to identify the parent chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what the student called it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so what is the parent chain? It is a nonane, right? So now we just need to decide where's carbon number 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's not going to matter either end, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the last question we need to ask ourselves is this branch substituent a 1,1 dimethylpropyl? Well, this is 1A, 2A, 3A. So is this 1,1 dimethylpropyl? It is. That's what that group is called. So last but not least, did the student put it together correctly? Is it on carbon number 5? Yes. Is it a nonane? Yes. So then this student is correct. Do we agree on 16? Right. Where'd my structure go? There we go. Let's do it. Okay, let's see if this one's named correctly. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Well, we know the student got something wrong, right? Because it's not a heptane, it's an octane. So, and we're numbering from this end because he gets me to my first substituent on carbon number 2. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's see. We've got methyl, methyl, methyl. What is this? That's a propyl group, right? So the name here is 2, 3, 4, what? Right, trimethyl. So that part's correct. Student got that part right. But there's not a butyl group on carbon 4. It's a what? Propyl group on carbon 4. 4 propyl. Oop, I was starting to write what the student wrote. Octane. It's 8 carbon chain. We good on this one? All right. Okay, 3-ethyl 5-propyl decane. Let's see if this is a decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So do we think that's a decane? Is there any other configuration that we left off? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, that's an option. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So either way we count it, it's an 11 carbon chain, right? Because 1, 2, 3 gets me my first substituent. 1, 2, 3 gets me my first substituent. So it's an 11 carbon chain. So student made a boo-boo there. This is a substituent, and this is a substituent. So this is an ethyl group, and this is a what group? That's a propyl, right? So the student did get that part right. It is 3-ethyl, it is 5-propyl, but it's not a decane. What is it? What's an 11 carbon chain called? Undecane, right? So if that's all you did, you called it a decane when it's actually a undecane, that's like -1/2. That's a really small mistake, right? Because it's 3-ethyl 5-propyl. It's just undecane, not decane. That's a very, very, very minor mistake. Okay, let's count this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can get 5 carbons no matter how you spin it. So is this a heptane? Are you getting a 7 carbon chain anywhere? No, so it's definitely not a heptane. So let's just see. 1, 2, that gives me substituent on carbon number 2. 1, 2, that gives me 2 substituents on carbon number 2. So we want to count from this end. Because if we count from this end, that's only got 1 substituent on carbon 2, whereas counting from this way gives me 2 substituents on carbon 2. So that's higher ranking than that. So 1, 2, 3, 4, 5. So 2, 2, 4 trimethyl, that part's correct, right? Because that's a methyl, and that's a methyl. That part's correct. But it's not a heptane. What is it? Pentane, right? Again, that's a really small mistake. It's a minor mistake. All right, I'm gonna move the screen up so I don't have to sit on the floor. Reach down there. Okay, we're calling this a heptane. Let's see if we agree. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if we're going this way, 1, 2, 3, 4, 5, 6, 7. That gives me 2 substituents. If we go this way, 1, 2, 3, 4. That only gives me 1 substituent. So which way do we pick? The one that gives you more substituents or fewer substituents? More substituents, right? So we're going to count from this way, right? Because if we count this way, we only got 1 substituent. We count this way, we've got 2 substituents. So 1, 2, 3, 4, 5, 6, 7. Okay, 3-methyl 4-propyl. That's correct, right? Because that's what the name is. 3-methyl 4-propyl heptane. So yes, that one's correct. The student got that one right. Okay. Last part, we're going to draw some structures. I gave you the option. All this right here, that's condensed molecular with the C's and H's. So if you are still feeling more comfortable drawing C's and H's, because some students are at the beginning, then that's fine. I prefer to draw skeleton though. Yeah, I do too. It's especially substituents. They just jump out, I think, a lot more easily. Okay, this is a heptane, so it's 7. So 1, 2, 3, 4, 5, 6, 7. On carbon number 4, 1, 2, 3, 4. So there's carbon number 4. We've got dimethyl ethyl. So there's the ethyl, and there's the 1, 1 dimethyl. Do we agree on that part? And then we've got 2, 3, 2, 3 dimethyl, 2, 3 dimethyl. Did you get that one? All right, last one, pentane. It's 5-carbon chain. 1, 2, 3, 4, 5. 2, 2 dimethyl, 2, 2 dimethyl. I think that's the last one, isn't it? All right. So that's where we will stop.